Hello, this is a short tutorial showing you how to move from MATLAB to Python if you are interested in doing so. So let's get started. I'm going to start with a very simple example of making a sine wave in MATLAB, and then we'll do the same in Python and compare the two. So I'm going to start with making my x variable, which is going to be from 0 in spaces of 0.01 to 1, and y, which equals sine of 2 times pi times my x, close the brackets, and then we do figure plot xy. We run that and we get a nice looking sine wave. Now let's go and do the same thing but in Python. So the easiest way to get started with Python is by downloading a package called Python XY. If you go to Google, type in Python XY, it'll take you to a page that looks like this. If you're using Windows, you can simply download one of these executables, and it's simply next, and you have everything installed that you need. Within that package is a program called Spider, which looks very similar to MATLAB, as we can see here. We have an editor window, we have a file explorer and a variable explorer. So let's get started in trying to make our sine wave. So the first thing we need to do is import a package called NumPy. Now this looks a little bit strange when you're coming from MATLAB, because this kind of thing doesn't happen in MATLAB. But just bear with me, I'm going to write out the code first and then we'll talk about it. So we're going to say that x equals np. Now this refers to our package NumPy, and we're going to use a function inside this called arange. And when I open that bracket here, I get a little description on the right here which tells me how to use this particular method. So I want to put in a start range, a stop range, and a step. So I'm going to go from 0 to 1 in a step size of 0.01, just like we did before in MATLAB. And to make the y variable, we're going to say y equals np.sine 2 times numpy, or np.pi. This gives me my value of 3.1415. Multiply that by x, close the brackets, and we're also going to need to import a package for plotting, which is called matplotlib. As the name implies, this is very similar to MATLAB's plotting language. So we go to plt.figure, and that looks very similar, doesn't it? And then we say plt.plot xy, and then finally plt.show, and we have our brackets. These brackets at the end just tell the interpreter that this is a method that we want to invoke. We can run this either by pressing the play button, or we can press F5 as it says there. So I'm going to just name this sine waves, save that, and this asks me how I want to run it. So we're just going to run it in a dedicated new Python interpreter, and we'll take this thing here called interact with the Python interpreter after execution, and then we just hit run, and here we have our sine wave. So I'm just going to close this and run this again, just to show you that when we run it again, yes, we want to kill the previous one, but when we run it again, it doesn't ask me those options again, it just remembers them. So this is our sine wave. It looks very much like the MATLAB sine wave. I'll bring the two up side by side just to compare them. The color schemes are almost the same as well. So that is how to make a very simple sine wave in NumPy. So the bits that are different from MATLAB, first of all, are these import statements here. These are basically packages and libraries which have been written to work inside Python to do various things for you. So this NumPy handles all of your arrays and your matrices. This matplotlib is a library for plotting in a similar way to MATLAB. When I type in np dot, what I'm saying is that within this NumPy library, and it's called np because I've given it a short name here, within this library I want to use this function called arange. In this simple function we can state our start and stop range with the step size. And here we say within this NumPy library, bring out the sine function, and again here within the NumPy library, get me the value of pi. So this plt thing here, which is related to this matplotlib, I'm using a method in there called figure, which brings up our figure window. This is a standard plotting function for x and y, and this final line here is what actually makes the plot show on the screen. So these are things that you don't have to do in MATLAB, but you do have to do in Python. The reason for why is a little bit complicated, but this is a good way just to get started, to get some familiarity with what's going on. Now we will compare the code side by side for the MATLAB and the Python version. So bring that up here, close that there. So the major differences are that in MATLAB we don't have any import statements, which at first it might seem confusing in Python, but there is a very good reason for this, and you'll learn to appreciate this as you do more Python. And then the creation of the x and y, the syntax is a little bit different, and we're using different methods, but essentially the thinking behind it is exactly the same. That's all for this video. I hope you enjoyed it, and look out for the next one. Thank you.